Hello everyone, welcome to this lesson. So in this lesson, we're going to continue our discussion on solving systems of equations, right? And we said that the first two classes are going to be a foundation to when we're going to actually start talking about solving systems of equations. Now in the previous lesson, we introduced the concept of an array, and we said an array is an object that we store data in. It can either be a vector type, which is a single column or a single row, or it can be a matrix, which is a mixture of mixture of columns, mixtures of rows. Now, in this lesson, we're going to focus entirely on matrices, and we're going to talk about a few properties of a matrix, and also we're going to talk about matrix manipulation. And what I mean by manipulation, I mean about how do we add two matrices, how do we multiply two matrices, or how do we transpose a matrix. Okay, so what we're going to be doing is we're going to be adding a matrix A and matrix B, and we're going to be displaying it here. We're going to be multiplying matrix A and B displayed here. We're going to be transposing matrix C here. Now, I went ahead and wrote the code. I found that it's going to be much more efficient if I explained it and you saw the code in front of you than write it with you. So let's actually start. So let's go through what is the main outline of the code. Now, as we did with the previous lesson, the first thing that we did is we created our arrays. Now, in this example, or in this lesson, we have three matrices. We have matrix A, matrix B, and matrix C, right? Now, after we create our matrix, we have to input our values from Excel into VBA. So we're going to have that type of code here. I'm going to go through the code in detail, but right now we're going through what is the main outline of the code. So we create our matrices, right, A, B, and C. We input the values in them. Then we go ahead and do the manipulation of the matrices, right? So the first task that we want to do is add matrix A to matrix B. So we're going to have a code for that, and also multiply matrix A and matrix B. We have a code for that. And as you see, if you see with this code compared to the adding, multiplying matrices is not as straightforward as adding matrices. And also the final code we're going to go through is how to transpose a matrix. Now, in terms of creating matrix A, B, and C, we use the keyword dim, right? So keyword dim not only creates a matrix, but it gives it dimension. This is where the word gets its name from. So it's a dimensionalizing keyword. So here, the dimensions of the matrices that I want, there are 3 by 3 matrices, right? 3 rows, 3 columns. So I went ahead and said A 3 3, dim B 3 3, dim C 3 3, and also I created this one for the transpose, right? So I could create other matrices to store my addition and multiplication, but I went ahead and just when I create my multiplication or addition, I right away display it on the Excel instead of storing it into a variable inside of VBA, then display it. And it's going to become clear as we go through this. So this is our creation of the matrices. Very simple. So let's actually go ahead into inputting the data into those created matrices or created arrays. Now, we said that since we're dealing with rows and columns, we're going to be using a nested loop, right? I is convention for rows, J is convention for columns. So basically what this code does, it goes through row 1, inputs this number, this number, this number, then it goes through this number, this number, this number, this number, this number, this number. Okay, so I added all 3 matrices here. So we're gonna have Aij is equal to cells, and I related it to these cells and columns, and these cells and columns, and these cells and columns. So for the first, say, let's go through this. For the first loop, if I is equal to 1 and j is equal to 1, then it's going to input this first number in A, first number in B, first number in C here. Then for the next loop is gonna get this, get this, get this, and then it's gonna get this one, this one, this one. And you can see that it's actually inputting A, B, and C simultaneously. And this is actually a way to make the code much more efficient. Instead of making 3 nested loops, one for each matrix, so we can actually input the value for each one of them using just one code here. Okay, so that's inputting data into matrix A, B, and C. So let's go ahead and for the second piece of this lesson, which is add matrix A and B. And adding matrix A and B is very, very simple. It's a direct addition. I take this address, which is 1, 1, add it to this address 1, 1, take this address 1, 2, add it to this address, and so on. So we keep adding each cell to its corresponding cell in the other matrix. Okay, so I went ahead again, we're still using a nested loop. For I is equal to 1 to 3 since we're dealing with 3 rows. For j is equal to 1 to 3 since we're dealing with 3 columns. And I went ahead and actually said related whatever that addition is to be equal to whatever this cell. So I just related this to this cell or these set of cells here. And you can see that is direct addition here, right? So for instance, if we say for I is equal to 1 and for j is equal to 1, that's going to be A11 plus B11, okay? And if I run this code, so let's actually comment this out. And let's actually run this code here. Let's see if it's related properly. So this is 18, so this starts at 18 plus I. And this one is still 1 plus j. And okay, so it's related properly. Let's see if this is related properly. This is at 13, so it's 12 plus I. And B is also 12 plus I. And 1, 2, 3, 4, 5, 6. So yes, 5 plus j. And this is 1, 2, so it's 1 plus j. So in terms of C, so C starts at 25. So that's 24 plus I. So let's go ahead. So if I run this code, so what it's going to do is it's going to create these matrices. It's going to input the values from these 3 sets of cells into VBA. Then it's going to perform the addition and at the same time it's going to display it here. Okay, so here is error because there's supposed to be end sub down here. Okay. So if I run this, all right, perfect. So you can see that it added properly. So 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 0 is 1, and so on. So now I want to pause here and talk about a few special types of matrices, especially matrix B and this resulting addition. Now, if you see here, we have this diagonal here. Now, this is called the principal diagonal. It's the diagonal that is from the very top left to the very bottom right. Now, there are other diagonals in the matrix, for this diagonal, for instance, this diagonal, for instance, but this is the main matrix diagonal. It's called the principal diagonal. Okay, now if the principal diagonal is all 1s and the rest of the matrix is all 0s, that is the very special type of matrix. It's called an identity matrix. Okay, now when I added A to B, I got this matrix here. Now this matrix is made up of all 1s, and this is also a special type of matrix called a unit matrix. And the reason it's called a unit matrix because the value in each one of those cells is only 1 unit. Okay, now this is called the principal diagonal. Now this diagonal that is the same from the very top right to the very bottom left, this is called the principal anti-diagonal. Okay, so principal diagonal, principal anti-diagonal, this is referred to as an identity matrix, and this is referred to as a unit matrix. So let's go ahead to the second part of the lesson, which is multiplying matrix A and B. And multiplying 2 matrices is not as straightforward as adding 2 matrices. And this is how you would multiply 2 matrices. It's quite involved, but let's actually go ahead and go through what is the mechanics of it. So let's work on how we get the top 3 values, this value, and this value in the first column. So this is how you get it. You get A1 multiplied by x1 plus A2 multiplied by x2 plus A3 multiplied by x3. So if we add those 3 multiples, now I got the first value here. Now, if I take the same first row and I do the same thing with that second column here, I get the second value. And if I take this first row and I do the same thing with the third column here, I get the third value down here. Okay, now I have the first row in my multiplication matrix. Now, what about the second and third row? Well, I'll do the same thing. I'll take this B row here, and I will do the same thing. Take B1 multiplied by x1, B2 multiplied by x2, B3 multiplied by x3, got the first value. Then B1 multiplied by y1, B2 multiplied by y2, B3 multiplied by y3, I got the second number. I do the same thing with B and Z, and I got the third number. So how do we get the bottom row here? And you kind of get the idea. We take this row C, take C1 multiplied by x1, C2, x2, C3, x3. First number, do the same thing with the y column and x column. And now we have finished our multiplication. So you can see it is quite involved as opposed to just direct addition when it comes to adding two matrices. So the first thing when it comes to coding, I want you to see that we're going to have three loops. So let's actually go through where are the loops gonna come from. Like when we're say inputting data into a matrix, we see that we're moving between we're choosing say a row and moving between the columns, and the second row moving between the columns. So first of all, I need a loop that's going to move between the A row to the B row to the C row, right? And when I am in the A row, I want a loop that is going to be going from the X column to the Y column to the Z column. So you can see that we have two loops here. But I also want a loop that is going to be doing my multiplication and addition. I want a loop that is going to take A1 multiplied by X1 plus A2 multiplied by X2 plus A3 multiplied by X3, which means the third loop is going to be a sum loop, right? So let me repeat this again. So I'm going to have one loop that's going to go from the A row to the B row to the C row, okay? And within each one of those, I want a loop that's going to go through the X column, Y column, and Z column, right? And within each one of those, I want a loop that's going to do my multiplication and addition. A1 times X1 plus A2 times X2 plus A3 times X3. Okay, so actually let's go ahead and see the code. So that's first loop for I is equal to 1 to 3. That's going to move us between A, B, and C. Then we have a loop K, again 1 to 3, and this is going to move us from X to Y to Z. And you're going to have this J loop 1 to 3 that is going to do, the first loop is going to A1 say multiplied by X1, then the second loop A2 multiplied by X2, third loop is going to be A3 multiplied by X3. The same thing is going to be done for the Y and the Z. So let's actually go through. So say I is equal to 1, which means we're dealing with the A, and say for K is equal to 1, that means we chose this first column, X. We're gonna of course initialize the sum is equal to 0, and let's say J is equal to 1, right? So it's gonna be sum is equal to sum A11 multiplied by B11. Okay, so A11 is this, right? So A1 multiplied by X1. So that's the first one. So we're going to go now J is equal to 2, right? So sum is equal to sum plus A12. So what is A12? That's A2 multiplied by B2, and the K is 1, 2, 1. So 2, 1 is over here, X2. A2 multiplied by X2. So if we go to J3, right? So it's going to be sum is equal to sum A, now it's 1, 3. Right, so 1, 3 is going to be A3 multiplied by B3, 1, and that's going to be X3. So you can see how we chose that first column, A, then the second loop shows X, and the third loop went through summing and multiplying those three numbers, right? So after this loop have summed and multiplied those numbers, right, I am done with this first value, right? Because when I multiply and add this A column with this X, this A row with this X column, I had this first number here. So after I do that, I'm gonna have this very simple display code. And let's actually see if the display code, so I want to do 18, so that's 18, and it's still 1, 2, 3, 4, 5, 6, so it's 5 plus k. And you can see 5 plus k because k is the one that controls the columns, right? So relatively simple code if you kind of know the purpose of each one of the loops. But at the very essence of it, it's actually a sum code, right? As you can clearly see from this. So let's actually go ahead and run this. Okay. So you can see actually the principal diagonal here, as opposed to this, is made up of zeros, and everything else is in the matrix is made up of 1, right? So the last thing I want to actually go through is transposing. And basically transposing is turning a column into a row or turning a row into a column. That's the process of transposing. And basically, the essence of the process of transposing is the rows become columns and the columns become rows. And that's in terms of the address. Okay, let's see what I mean by that. So let's take this row, for instance. So this is going to be 1, 0, 1, right? So this is a column. And if I transpose this column, I'm basically going to turn it into a row, which means I'm going to have here 1, 0, 1. So this is the process of transposing. I took A1, A2, A3, and I put it in this form, right? So now let's take the address of 0 here. The address of 0, this is second row, first column. So that address is 2, 1. But what about this one? This is a first row, second column. So that address is 1, 2. So 2, 1, 1, 2. You can see that the rows and columns flipped. What was the row became the column. What was the column became the row. Okay. So let's take this, for instance. We have 1, 0, 0. So if I transpose it, it's just going to be 1, 0, 0. So again, let's take the address of, say, this one here, right? So the address of this one is first row, second column, so 1, 2. And this one here is now 2, 1. So you see what was the columns became the rows, what was the row became the column. And this is just going to be 1, 1, 1 if I transpose this. So so let's take this, for instance. This is 1, 3. Now it became 3, 1. Okay. So yeah. So let's go ahead. So the reason I'm emphasizing this, that the I becomes a J or J becomes the I, because that's going to be the essence of the code that we're going to be writing. And here's the matrix that I created, CTIJ. So this is the T stands for transpose. So the CTIJ is going to be equal to the C, but JI. In other words, if CT is equal to, say, 1 and 2, right? So the 1 and 2 in the transpose is going to be equal to C, 2, and 1. And what's going to be the transpose, the value in the transpose at 1 and 3 is going to be equivalent to the original C at 3 and 1. So very simple. That's the idea of a transpose. What the row, the address of the row becomes the address of the column. The address of the column becomes the address of the row. So I went ahead, whatever we create, so that's the CJ, the C that we inputted here, and I just changed, this is IJ and this is JI, only on the premise that with a transpose, you just, the address in terms of the rows and columns is flipped. And this is just a code that displays this in the proper cells. So this is so this is going to be 24. Plus I, and still the same 1, 2, 3, 4, 5, 6. So it's 5 plus J. So if I run this, we're gonna get the same thing that I've written down here. So right, perfect. So we have 1, 1, 1. Now it became 1, 1, 1. Now we have 0, 0, 1. Now we have 0, 0, 1. Now we have 1, 0, 1. Here 1, 1, 0, 1. Okay, so the main difference that I did here, the example that I gave initially, I took a column and turned it into a row, but in terms of this transpose, we took this row and made it into a column. We took this row here it turned into a column. We took this row here and we turned into a column. Okay, so in this lesson, basically, we focused primarily on properties of matrices and how to manipulate a matrix. The main properties that we went through are basically the principal diagonal, the main diagonal of a matrix, and also this other one is called the the principal anti-diagonal. This is not commonly used, but I thought I would share it with you. Two of the most common also types of matrices we have, this is called a identity matrix, where the principal diagonal is made up of ones and everything else in the matrix is zeros, and a unit matrix where basically everything in the matrix is made up of one unit. When it comes to addition, we just directly add. When it comes to multiplication, we found out that it's a little bit more involved. We have a loop here that goes between this row, and this row. We have another loop that moves between this row, and this row. And the third loop is basically a sum code that multiplies each one of these and adds them, right? And this is the full-blown version of what it looks like. Okay, and a transpose is basically changing the address of in terms of the rows and columns, right? The columns become rows and rows become columns, and you can see here we had 1, 1, 1, and now it became different here. This has an address of, say, 1 and 2. This address became 2 and 1, and we took this type of idea and we implemented in the code by saying that the transport ij is equal to cji. Okay, so that would really mark the end of this lesson, and I will see you in the next lesson.